Hello, and thank you for joining us today. What we're going to look at is an example of how the product rule and the generalized power rule can be used together to find the derivative of a function. So over to the right, just a couple reminders. Remember that the derivative of f times g is the derivative of f times g plus f times the derivative of g. And remember that the derivative of a power of f is n times f to the n minus 1. Notice that kind of looks like the power rule, but then we multiply by the derivative of the inner function, the f. So here we have f of x equals 4x minus 1 to the third times 2x plus 5 to the fourth. And our goal is to find the derivative of this function. And we're also going to manipulate the derivative algebraically to show that there is a useful form of this derivative. So on the surface, what we have is a product. So we know that f prime of x is equal to, so it's the derivative of 4x minus 1 to the third times 2x plus 5 to the fourth plus 4x minus 1 to the third times the derivative of 2x plus 5 to the fourth. There we go. Just barely fit that there too. Okay, so the derivative of 4x minus 1 to the third. So the derivative of something to the third is 3 times the something squared. That's using this generalized power rule here. And then multiplied by the derivative of the something. Now the derivative of 4x minus 1 is 4. So I'm going to say times 4. And then that's times 2x plus 5 to the fourth plus, now we have a 4x minus 1 to the third. And the derivative of something to the fourth is 4 times something to the third times the derivative of the inner something, which is 2. Okay, so that's our product rule as well as our power rule. Okay, so continuing on here, let's pull together some like terms here. Notice that here we have a 3 times a 4, so that can easily be pulled together as 12. That is an equal sign there. 4x minus 1 squared times 2x plus 5 to the fourth plus, and over here we have a 4 and a 2, so we're going to call that 8, and then times 4x minus 1 to the third times 2x plus 5 to the third. Now ordinarily that would be considered sufficiently simplified, but we're going to take it one step further because coming soon in this course, we're going to be taking derivatives and setting them equal to 0, which means that the factored form of the derivative is going to be very useful to us as well. So I'm just going to put a little hatch mark here to remind you this is going to be okay for now, but we're going to want to go further later. So in looking at this, if we're going to factor, we have to factor something common from each side of the addition sign. So notice we have a 12 and an 8, so that's going to be a 4. I'll put the equals here. Looking at the factors of 4x minus 1, we have a square and we have a cube. So I'm going to call that 4x minus 1 squared. And over here we have powers of 2x plus 5 to the fourth and to the third. So I can factor out 2x plus 5 to the third. And now let's see what remains. Now since there is a chance for parentheses inside, I'm going to use brackets to set this off. So if I factor a 4 from the 12, that leaves me with a 3. We're factoring out both factors of 4x minus 1, so there's not going to be any 4x minus 1s there. And we're factoring out 2x plus 5 to the third from 2x plus 5 to the fourth, which is going to leave us with 2x plus 5. And then plus, now we're factoring a 4 from the 8, which leaves us with 2. We're factoring out 2 factors of 4x minus 1, which leaves us with 1 behind, because that was a third. And then all 3 factors of 2x plus 5. So that's done. And now what we're going to do is simplify within the brackets, because remember, a simplified expression is something that's either completely factored or completely multiplied out. The expression in the brackets is neither, so the easiest way to handle that is to just multiply everything out. So, looking at that, now I'm going to go back to parentheses here because I'm going to simplify right below this here. So this is 6x plus 15 plus 8x minus 2. So that looks to me like, go back to the original color, 14x plus 13. And this is the factored form of the derivative.